This is the AQA GCSE Mathematics practice. It's a foundation paper and it's paper 1, which means it's a non-calculator one. As you can see here, it says these questions are from past papers covering topics and skills based on the advanced information to help you prepare for the exams this summer. It is a standard number of marks, 80 marks, and the time is 1 hour and a half. So let's start. Question 1 is one of these questions where it's just testing your knowledge. This is facts to do with circles, and you can see here that we have a diagram with different lines labelled, and they tell us that O is the centre of the circle. We have parts A and B. Part A says the line OA is A, and we meant to circle the word that completes the sentence. We look for OA. O is from the centre to the outside of the circle. That means that's the radius. So let's circle it. Part B says what the line ST is, and we look for a line ST. Here is the line ST. As you can see, it's a straight line that just touches the outside of the circle, and that means it's a tangent. Make sure you learn your circle facts and circle names. Question 2. Question 2 is converting, and they're asking us how many millimeters are there in 7.5 centimeters, and this is a fact that you need to know, that you need 10 millimeters to make 1 centimeter, or in other words, 1 centimeter has 10 millimeters in it. So you can see that 1 times 10 will give us millimeters. So we need to take that and multiply it by 10. When you multiply it by 10, the decimal point will move to the right and we'll end up with 75. Let's circle it. Question 3. Question 3, it says here's a rectangle, as you can see in the picture. It says not drawn accurately, so that's just, we rely on the measurements given to us. It says work out the perimeter. Now the perimeter is the outside of our shape. So we're going to have to add what we have. So we have a 7 plus a 5. But remember, it's all the way around, so we're also going to have a 7 on the bottom and a 5 on the other side. So we have another 7 and another 5. Now it's up to you how you like to do your addition. You could basically just go adding through, or you could spot any patterns. In this case, I'm going to say 7 plus 7 is 14, 5 plus 5 is 10, 14 plus 10 is going to give me 24. So it's going to be 24 centimeters. Question number 4. Question number 4, let's push it to make up so you can see the full question. And this is telling us that we have a triangle and it is drawn accurately. In other words, the information on this diagram is correctly describes the triangle. And we notice it has 2 lines, and these 2 lines tell us that that side of the triangle is the same as that, the same length. Now we need to find, and it says tick 2 boxes, what type of triangle is it? So if it has 2 sides the same, that means it's isosceles. If it has 3 sides the same, it would be equilateral, so it's not equilateral. And scaling means they're all different, so isosceles is one we're after when it's 2 the same. But notice we need to do another fact. We've got one of them, but we need another one. And here we're talking about acute angles and obtuse angles. Obtuse angles means they're bigger than 90. Acute angles means they're less than 90. And as you can see, none of the angles inside this triangle are more than 90. So that means it's acute. We'll cross off that one. There we are, we've ticked 2. We're on to question 5. And question 5 is a calculation question. Let's have a little look at it. And it says we have 23.7 take away 2.5 times 8. Now remember, whenever you're doing one of these that has several operations in them, you need to remember your order of operation. You first will do your brackets, followed by any powers, then you'll do your multiplication and your division, and at the end you will do your addition and your subtraction. So in this case we have a subtraction and a multiplication, which means we're going to do our multiplication first, so we're going to focus on that first. Now how you do that is up to you. You can either do repeated addition, 2.58 times, or you can do multiplication in a grid, whatever suits you. So we're going to basically say 2.5 times 8. 8 times 5 is 40, carry 4. 8 times 2 is 16, 16 plus 4 is 20. we had 1 decimal place here, so we're going to put 1 decimal place, and so when you did this calculation you end up with 20. There are other ways of doing it, just make sure you can do your calculation. Now let's go back to what we had here. Here it said we had 23.7, take away 20. Notice I've kept the order as in the question given to me. Anybody can see that 23.7 take away 20 will leave us with 3.7. So let's write our answer nice and clearly. 3.7, there we are. Okay, in fact let's make the point more obvious. Let's move down. Question number 6 is a substitution question. It says given that P is equal to 3 lots of E plus 5 lots of F, work out the value of P when E is worth 4 and F is worth -2. So in other words, we're going to do a calculation which means 3 lots of E, and E is worth 4, plus 5 lots of -2. Okay, remember that's a negative, so I'm going to put brackets there to just make sure I don't go messing it up. Like before, order of operation means we will do, just like we did before, multiplication before addition. So in this case, I'm going to work out this multiplication. 3 times 4 is 12. I'm going to work out this other multiplication over here. 2 times 5 is 10. The positive times a negative gives me a negative. And now we can do our addition. So we're adding 12, adding a -10. In other words, we're taking 10 away, which will leave us with 2. So our answer for this question is 2. Question 7. It tells us that a table shows the number of desktop computers. So going down in these columns we have desktop computers and laptops. So going across in the rows we have the laptops in 50 households. So if we looked inside here and added all that together, we'd get 50 households. This is telling us how many desktops: none, 1, 2 and 3, and again how many laptops: none, 1, 2 and 3. Part A says how many households have 2 laptops. So we're looking for laptops, we're looking for anything that has 2, and you'll notice that we end up with all of those. All of those households have 2 laptops. So we can add them together to get an answer. 1 plus 8 is 9, 9 plus 5 is 14. So for that question there, the answer is there are 14 households that have 2 laptops. Part B says how many households have more laptops than desktop computers. So this is going to compare laptops to desktop computers, and we're looking for the ones where there's more laptops than desktop computers. So if there are no laptops, we can't have any of these answers here, because that means they definitely have more computers than laptops. We're looking at this one here. It says they have 1 laptop, so they're allowed to have no desktop computers, but we cannot have these because this means it has more, and we want how many households have more laptops, and in this case here they have equal number of laptops and desktops, and here we have people having more desktops than laptops, so we have that 5 there. Now we're looking for 2, so if they have 2 laptops, they're allowed to have one person has no desktop, one household has no desktop computer, and we're also allowed to have this one, because that means there's 1 desktop computer and 1 is less than 2. But we cannot have these because these are 2 and 3, which are more than 2, okay, or equal to 2, and we want things on. So again, same idea, 3. So 0 is allowed because 0 is less than 3, 1 is allowed because it's less than 3, and 2 is allowed because it's less than 3, but we're not allowed to have that one because that there has more desktop computers, or the same as laptops, and we want the ones where there's more laptops. So now we'll add the numbers that I've circled there. So we're going to add a 5 plus a 1 plus an 8 plus a 3 plus a 2 plus a 1 to get our answer. Okay, let's just check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Do your addition however you want to do, just make sure that it comes out right. So we have 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1 is 7, 7 plus 8 is going to be 15, 15 and 5 comes out to 20. the answer for this one is 20. Okay, let's move on to question number 8. Okay, looking at question number 8, it's three questions all to do with ratios. Part A, Part B, Part C. And the first one is simplifying a ratio. So when simplifying a ratio, you need to know what number you can divide both of the components by. So if you're good at your times tables, you'll spot that 8 fits into both of those. But if you're not so good at your times table, you'll spot that they're both even numbers, and if they're even numbers, it means we can halve them. So if you halve 50 and 6, you're going to get 25 and 3. So 25 and 3 would mean 28. And if you halve 24, you're going to get 12. Once again, you have even and even numbers, so we can halve it again. Half of 28 is 14, and half of 12 is 6. Once again, they're even numbers, so half of 14 is 7, and half of 6 is 3. We noted that 7 and 3 are prime numbers. That means that there's no point in trying to find a factor that will work for them. So we found our answer. Our answer is 7 and 3. But as I said, if you knew your times tables, you know that 24 divided by 8 is 3, and 56 divided by 8 is 7, and you could have got there in one step. It's really useful knowing your times tables. Part B. Part B says here's a ratio, 5 to 4, and that ratio, 5 to 4, we want to write it in the form n to 1. In other words, the second value is going to become 1. And in ratios, the way to do that is to find something that you can do. Can you multiply or divide to make it 1? Now, any number divided by itself gives you 1. So in this case, I'm going to take 4, and I'm going to divide 4 by 4, which will give me 1, which is what I wanted. But recall that in ratios, what you do to one side, you will do to the other side. So on that side, I'm also going to divide by 4. This is a non-calculator paper, and they haven't asked me to write it as decimal, so I can leave it as a fraction. So in other words, 5 divided by 4 could be written as a fraction. So I can just write our answer, which is 5 over 4, and in this case over here, 1. If they asked for decimal, we could have done it, but there's no point wasting time at this stage. Part C says share, so we have a total of £180 and we're going to share it in the ratio 1 to 9. That means there is 1 part going to go here and 9 parts is going to go over there. So in total, we can see that we have 10 parts that we're going to split our total into. So we're going to take 180 and we're going to split it into 10 parts. And if you divide by 10, it's nice because we just divide by 10. So that's going to become 18. So 1 part is worth 18. In this case here, 1 times 18 gives us 18. On this side over here, we're going to have 9 times 18. If you don't like doing that in your head, just do a little calculation on the side. 9 times 8 is 72, carry 7. 9 times 1 is 9, plus 7 is going to be 16. So we end up with, on this side, 162. So we're going to end up with an 18 and 162. £18 over here and 162 over there. We must check to see that it does actually add up to the 180. 2 plus 8 is 10, carry 1. 6 plus the 1 we carried is 7, plus that one is 8, so that looks like 8, and 1, so 180, so that works, and we've got our 2 marks. Very good. Let's move on to question number 9. So let's have a look at question number 9, and question number 9 it tells us that Jack is 1.28 meters tall. He has a tent, and the tent is in the shape of a triangular prism. This diagram shows the front of the tent. They've given us some measurements in meters, clearly not drawn accurately because meters would be far bigger than that. And it tells us the base of the tent has been drawn to scale, so it is actually to scale. Complete the scale drawing to work out if Jack can stand up in the middle of the tent. Show how you decide. So we notice that they have already drawn down here, let's push it up so you can actually see. Down here they've actually drawn the base of the tent, and they tell us that that's already been drawn to scale. Here we have a scale, and it tells us that 1 centimetre on this drawing is the same as 20 centimetres. However, what we started up with over here is meters. So that kind of tells you a hint that we're going to have to change our meters into centimetres. And remember, when you're going from meters to centimetres, you have to multiply by 100. So I'm going to look for all the cases where there's some meters, and I'm going to change them to centimetres. So there's the first one, his height, and his height is 1.28 times 100, which become 128 centimetres. Again, this one here, if I multiply that one by 100, I'm going to end up with 150 centimetres. This one here is the same, so this one's going to become 150 centimetres. And this one down here, when you multiply it by 100, is going to end up being 180 centimetres. So we're going to end up drawing 150, 180, 150. Okay. Now it tells us that we need to complete those scale drawings. So let's just check that they've actually got the base correct. They tell me that every centimetre is 20 centimetres. So when we measure this, make sure it's on the centimetre scale. You can see nearly, not quite there, but nearly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 and a bit, but let's pretend it's 9, like they said it's drawn to scale. So if it's 9 times 2 is 18, and a 0 would make it 180, which is what they've told us it's going to be. Okay. Now there are various ways of doing this to draw the drawing. You could get a compass, and that's probably what they want, but I'm going to improvise since I don't have a compass with me. Okay. And the way I'm going to improvise is I'm basically going to know that if these two sides here are the same, it's an isosceles, which means they're going to meet in the middle. So if I have here 9.2, which I know it's meant to be 9, but they've gone and made a mistake when they drew this. So half of 9 is 4.5 and 1, so it's going to be 4.6. So we're going to end up being basically a right angle there. Now I do have a protractor with me to make sure I end up getting a nice 90-degree. So as you can see, there's my protractor, and I'm just trying to make sure I do get a 90 degrees. So what I'm going to do is I'm going to go just wanting to make sure I get a nice straightforward 90 degrees in there. I wish I had the smaller protractor to do this. What I'm going to do is I'm going to do it this way. I'm going to put the drawing, match the drawing there, get that in a 0. I'm going to go up to 90, and 90 is up there. So this is going to be where my lines are going to match up. So I'm just going to put that in there, and it means that since it's isosceles, they'll match up there. Okay. Now we have to draw something which is 150 centimeters. So I'm going to divide it by 20. So if we divide by 10 is 15, divide by 2, so half of 15 is going to be 7.5. So I want something that is 7.5 centimeters long. So I'm going to look on my ruler, here's 7.5, I'm going to match it onto there, so there's my 7.5, and I'm going to try and make sure it touches, so there we are, so that's the side there. And I'm going to do the same on the other side. Remember, it has to be 7.5, so make sure it does come out to 7.5. Okay, with a bit of error, but approximately there, so we'll be fine. Okay, so we've drawn it to scale, and now we need to check whether Jack can stand up, and Jack was 128 centimeters, so we need to know if that height there is more than 128 centimeters. So what I'm going to do is I'm going to measure it, and when I measure it, it comes out to just 6 and a bit, so I'm going to call it 6. So 6 centimeters, and each centimeter is worth 20. So 6 times 2 is 120 and a 0. So in this case, the height of the tent is 120 centimeters, and Jack was 128 centimeters. So no, he will not fit, because 120 is less than the 128 that we need. Okay. Let's do question 10. Question 10 tells us that we have 3 whole numbers, and each number has been rounded to the nearest 10. The sum of the rounded numbers, so after they were rounded, when they were then added together, came out to 70. Now obviously it's going to be a multiple of 10 because it's been rounded to tens. Work out the maximum possible sum for the original 3 numbers. So you could do trial and error for this one, or you could use a bit of reasoning. So we have three numbers, and each of those numbers, so we have three numbers, and each of those numbers were rounded to the nearest 10, and when they were added together it came out to 70. Now when you round to the nearest 10, if you have something which is 5 or more, you'll round up, and if it's less than 5 you round down. So if we want the maximum, we're going to end up with these numbers here going down. So can you see what we're doing? Because basically when they added it to be this, if we want to be higher, we will have been all rounded down. If they were rounded up, then we can't be higher. This number would have been higher and be bigger than possible. Okay, so that means that each of these numbers, the biggest it could have been, and because they're whole numbers, we're not worried about decimals, is something ending in a 4. So for example, we could have had something like 10 plus 10 plus 50 adding to 70. Remember, these have been rounded to the nearest 10. So what could they have been? Well, it could have been 14, because 14 would have rounded down to 10. The biggest number here would be 14, and the biggest number here would have been 54. If it had been 15, it would round to 20, and then you'd be getting a different answer here. They're asking us what's the possible sum. Well, you notice in each case we're 4 bigger than it was originally, so we have 3 lots of 4. So we have 70 plus 3 lots of 4 would be 82. So the biggest possible answer would be 82. Or you could just add those numbers and you'll see that it comes out to 82. Have a little think about it. There's some logic there if you think about it. Question 11 is to do with sequences. There's a part A and a part B. They tell us that there's a sequence that goes 5, 13, 21, 29. Circle the expression for the nth term. In other words, one of these expressions will help us get that sequence. Now that means that in each of these cases, in this case n equals 1, n equals 2, n equals 3, because that's just basically for the number of terms. Okay, so when we're checking these, we're going to substitute 1 into these, 2 into these, and see which gives us those answers. So I'll start with 1. Okay, 3 times 1 is 3, 8 take away 3 is 5, so it's looking good. Let's try using 2. 3 times 2 is 6, 8 take away 6 is 2, but that's not 2, so it didn't work. Let's move on to the second expression. Try n equals 1. 1 lots of 8 is 8. 8 plus 5 is going to be much bigger than that 5, so it didn't work. Let's try the third expression with n equals 1. 1 lots of 8 is 8. 8 take away 3 is indeed 5, so it looks like it's working. Let's check it with n equals 2. 2 lots of 8 is 16. 16 take away 3 is 13, so it is working. So at the moment it looks like this is working. Let's just check the last one to see. 1 times 5 is 5, 5 plus 8 is 13, and that is not 13, so you can clearly see now with confidence this is the one that's going to work. Part B tells us that there's a rule. The end-to-end rule for a different sequence, not that one, a different one, is to multiply the previous term by 2 and then subtract 5. So whatever we had before, you will basically times by 2 and then take away 5. They tell us that the second term in this expression is 2 lots of x plus 7, and the sum of the first 3 terms is 57. Work out the value of x. So actually this is a sneaky algebra question. So let's use our knowledge. It's a 4-mark question, as you can see down here, so it is worth giving it a go. So what do we know? We know that there are 3 terms. So we have one term plus the second term plus the third term. Why am I doing that? Because it says here the sum of the first 3 terms, so the sum adds to 57. So I've used this bit of information there. It tells me here that the second term in the sequence is 2x plus 7. So here we have 2x plus 7. So I've used that bit of information. Okay. Now it tells me that to work out the next term in the sequence, we use this rule. Multiply the previous one, so multiply that one by 2 and then subtract 5. So let's have a little bit of working space somewhere. So if I have 2x plus 7 and I take all of that and I multiply it by 2, okay, and then after you've done that, we will take 5 away. Sorry, I just noticed that. Okay, so if I double this, if I double that one, I'll get 4x. If I double this one, I'm going to get 14. So double 2 is 4, double 7 is 14. So I've done this bit, and now I need to take 5 away. So when I do that, I'm going to end up with a 4x here. 14 take away 5 will leave me with a 9. So we know that the third term is 4x plus 9. I'm going to use this to work out the first term, but remember, going backwards we do the opposite. So the opposite will be add 5 and then divide by 2. So once again, we need a bit of space somewhere to do that. I'm going to come down here, and we know that the middle term was 2x plus 7, and if we're going backwards, we need to, instead of subtract 5, add 5. So I'm going to add 5, okay, and after we add 5, then we're going to, instead of multiply, divide by 2. So once we've done all of this, once we've done all that, I will then divide it by 2. Okay. So what do we have here? We have 2x. 7 plus 5 is going to be 12. And then at the end, all of this is divided by 2. So half of 2x will give me x, and half of 12 will give me 6. So the first term was x plus 6. So let's go back up here and write it up, x plus 6. Okay, we're full marks. I think we've got a couple of marks there at least for our work. Right, so now we're going to use our idea of collecting like terms, and then we're going to solve this. So here I have 1x, 2x, 4x. So 1 plus 2x is 3x, 3x plus 4 is going to be 7x. So I have 7x. Okay. Here I have 6 plus another 7 plus another 9. So 6 plus 7 is 13. 13 plus 9 is going to be 22. Let's just check that. 9 plus 7 is 16. 16, 17, 18, 19, 20, 21, 22. Yes, 22. And all of that adds up to 57. So now we're going to solve this, and solving means keep balancing an equation until we find out what x is, because remember they're asking us what x is. So what we're going to have to do is take 22 away from this side and take away 22 away from that side. When we do that, that side will then disappear and we'll end up with just a 7x equals, and 57 take away 22, well 7 take away 2 is 5, and 5 take away 2 is 3. If we go backwards, let's just check. 5 plus 2 is 7 and 3 plus 2 is 5. Good. Now this is a multiplication, so the opposite multiplication is a division. So I'm going to divide that side by 7 and that side by 7. But 7's cancel to leave me with my x. And on this side, how many 7's fit into 35? If you know your times tables, you'll know that it's 5. But if not, you'll have to just count up until you get to 35. So in this case, our x is worth 5. Okay. That's actually a nice question. It just takes a little bit of practice to get through it, because there's many steps to it and understanding what they want. Let's move to question number 12. Now question number 12, they've given us a formula. Notice here's a formula, and they tell us that density is equal to mass divided by volume. They also tell us that there's a mass of solid A is 6 times the mass of solid B. The volume of solid A is 3 times the volume of solid B. Complete this sentence. The density of solid A is something times the density of solid B. So what I'm going to do is I'm going to substitute the information into this formula. So we have density equals mass. Now A is 6 times, so whatever B was, it is 6 times bigger. So the mass is on top, and it tells me it's 6 times bigger. Volume goes on bottom. It says volume of A is 3 times, so 3 times 3 the volume of B. Notice we can cancel because this is a division here. Yeah. So how many 3's fit into 6? 2. So what we actually have is that the density of solid A is, and you could either write twice times, you could try to say 2 times, because notice we have here times. Anything that shows that you know that you basically double, it's double the density. Okay. I don't like the English the way it's written there. You say twice times, doesn't really, 2 times, probably 2 times. You could even put a number 2 there. Yeah, but I still don't think it's fluent or the way they've written it. Let's have a look at question 13. Question 13 says we have Deepan and Nisha and they're planning a wedding reception. Each guest costs £40. The total is reduced by 5% if there are more than 60 guests. Nisha says, I want to invite 70 guests. Deepan says, if we invite 1/5 fewer guests, we will save more than £500. Is he correct? You must show your workings. Now, this type of question, there's normally several ways of doing it. You can see it's a 6-mark question, so there's quite a bit of workings to do. As long as you're clear, there are different ways of doing it, but as long as you're clear, you'll get several marks, and hopefully you can get all the way through and get all 6 marks. So what we want to do is we want to find out how much it would be for 70 guests. Then we want to see how much they would be saving if they had all those 70 guests, because that means they'll get this reduction. But we then want to see if they have 1/5 fewer, would that save them more than 500? So we first have to do the full calculation as if they're taking all the 70 guests. So let's do that. So in this case we have £40 times 70, because each person it costs £40, and 7 times 4, well 7 times 4 is 28, 0, 0. Okay, so that's a cost for all 70 guests. However, there's a total of 5% reduction. So this is where it's useful to know that 10% of any number, so 10% of 2,800 would come out to 280. You divide by 10. There are other ways of doing it, but this is a good one to do when you don't have a calculator. We don't want 10%, we want 5%. So if I halve 10, I get 5. So if I halve this one, I'm going to end up with 140. So this is how much they will save. Because it says here the total is reduced by 5%. So I can come over here and reduce it by 140. 0 take away 0 is 0. I'm going to have to borrow because 0 take away 4 I can't do. So I'm going to borrow over here. That becomes a 7. That becomes 10. 10 take away 4 is 6. 7 take away 1 is 6. 2,600. So that is how much is a total for 70 guests. Is 2,660. But we now want to know if they would save more than £500 if there was 1/5 fewer guests. So let's work out 1/5 fewer guests. So 1/5 of 70. So 1 times 70 is 70, divided by 5. Now again, if you know your times tables, you'll know that comes out to 14, but otherwise you might have to do division or go counting up until you get there. Okay, so we can say how many 5s into 7? 1. We're left with 20. How many 5s into 20? 14. As I said, it's going to come out to 14. So that's first 14 fewer guests. Okay, so if there's 14 fewer guests, that means that instead of 70 take away 14, well 70 take away 10 is going to be 60, 60 take away 4 is going to be 56, which means there are 56 guests. Okay, you can text it that way, doing 56 plus 4 is 60, 60 plus 10 is 70. Okay. Now notice we now no longer get the discount, because if it's over 60 guests you get a discount. This is not over 60, so don't get a discount. Okay, so now we'll work out the price for 56 guests. Okay, so we're going to say £40 times 56. You can use a grid method, you can use any method you want to do, but in my case I'm just going to say 4 times 6 is 24, carry a 2. 4 times 5 is going to be 20, 22 and a 0. So that's the cost for 56 guests. And the question is, if we compare that to that, is there more than £500 in saving? So if I add 500 to this, 2,200 plus 500 would be 2,700. That is not 2,700. So in this case here, no, he will not. He is incorrect. Okay, because when you compare those two, it's definitely not more than 500 in savings. Okay, but you could always, if you wanted to, you could always show that by saying 2,660, take away 2,240, 0, 2, 4. So basically that is less than 500. Okay, excellent. Let's move on to question 14. Question 14 is a graph, and the graph is showing us the distance time graph of a journey that Al makes. So here we have the distance, it's in miles. Here we have the time, and the time is going 10 a.m, 11 a.m, noon, 1, 2, 3. Alf claims that he stopped for less than 1/4 of his total journey time. Is he correct? Now, obviously, if the distance is changing, it means he's moving. But if the distance is not changing, it means he's stationary. So what we want to do is, when he's talking about stopped, is where he's stationary. So basically, it's this bit here. Yeah, that bit there is stationary, and that bit there is stationary. Now, I'll just mention at this point, I'm using a blue pen to make it clear what I'm doing, but in an exam you should use a black pen. So we need to find the total amount of time, and then we need to see if that time, the amount he stopped, also, and how much he did in total, is 1/4 of his total journey. Okay, so what do we need to do? Let's look what's happening. So this is 10, that's 11, so that is an hour. Okay, if that's an hour, in the middle that's half an hour, and if that's the middle, that's 15. So basically we're going 10, 10:15, 10:30, 10:45, 11, 11:15. You get my drift? Each of these boxes is worth 15 minutes. So when I go here, I have 15, 30, 45, 60. So this here is actually an hour long, okay, or 60 minutes. And if I go along here, we go 15, 30. So this one here is 30 minutes or half an hour. Okay, so the time he stopped is 60 plus 30, 90 minutes. Okay, so now we need to work out, is that 1/4 of his total journey time? Okay, now if it's 1/4, it means that there'll be 4 of them. Okay, so we could say 4 lots of this is the same as his journey time, or we could find out the total journey time and divide it by 4 and compare it. The choice is yours. I'm going to go for finding the full one, because here we know we have 60, here we know we have another 60, because each hour is 60 minutes. Yes, so we have 1, 2, 3, 4, 5. We have 5 lots of, so the total journey is 5 lots of 60 minutes. 5 times 6 is 30, and another, so that is the total journey time, 300 minutes. So if I work out 1/4, the question is 1/4 of this 90, or 4 lots of 90, does it make 300? And we can actually see that it's not going to be the case, but let's do it. So 1/4 of 300. Okay, now it depends how you like to do it. You can split that into half and then half again. So half of 300 is 150, half of 150 is going to be 75. Yeah, or you could do a little division where you have 300 and you divide by 4. Does 4 fit into 3? No. Does 4 fit into 30? It does, because 4 times 7 is 28. remainder 2. 4 into 20, 5, and you get your 75. But notice that that 75 is not the same as that 90. So in this case, no, because 90 minutes is not 75 minutes. Okay, good. After that long one, we have a shorter one here, and it says n is an integer. Integer means a whole number. And it says list all the values of n such that n plus 3 is bigger or equal to -1, always less than 5. But in looking at that, okay, I'm actually going to get rid of the 3 because I just want to know what n is. Yeah, that's what they're talking about there. So to do that, I'm going to do a bit like I did when I did the solving. I'm going to take 3 away from there. But if I do that, I'm going to have to do it from this one, and I'm going to have to do it from that one. So I'm going to take 3 away from this one, I'm going to take 3 away from that one, and 3 away from that one. If I do that, I have -1, take away 3, it's going to give me -4. 3 take away 3 leaves me with just the n. 5 take away 3 leaves me with 2. So in other words, n is any integer, any whole number that is equal or bigger than -4, -4, and less than 2. So in that case, -4 is allowed, -3, -2, -1, 0, and 1. But notice I don't put the 2 because it's not allowed to be equal to it. Okay, excellent. Let's have a look. Where are we? We're on to question number 16. 16 is a vector question, and it says the vector -2 or -2, 3 translates, that means moves, remember that means moves, A to B. And this one, remember the top one is in the x direction, so -2 means it's moving in this direction 2, and 3 means it's moving up 3 spaces. So when they moved A to B, it went to the left 2 and then it went up 3. Circle the vector that translates B to A. So we want to do the opposite, going back. So if we were to do the opposite, we'd have to go to the right 2, because that's the opposite of going left 2, and then we need to go down 3, because that's the opposite of going up 3. So we want something that is 2, and to go down is a -3. So we want something that is 2 and -3. So 2 minus 3, there we are. Okay. Question 17. Now question 17, as you can see, we have a table to complete, and there is also a graph or an axis so we can plot what they want. And they're asking us to complete the table of the values y equals 8 take away 2 lots of x. And they've done some for us, so we can just always check to make sure we understand what we're doing before we jump into doing the missing gaps. So when x is 1, y is 6. So when x is 1, so 1 times 2 is 2, 8 take away 2 is 6, so yes, it works. So let's put 0 in there. 2 lots of nothing is nothing, 8 take away nothing is 8. 2, when x is 2, so 2 times 2 is 4, 8 take away 4 is 4. 3 times 2, 3 times 2 is 6, 8 take away 6 is 2, so that's okay. 4, 2 lots of 4 is 8, 8 take away 8 is nothing. 2 lots of 5 is 10, 8 take away 10 is going into the negatives. Now notice that this is a linear equation. There's no squares, there's no cubes or a higher power. That means that we're going to end up plotting a straight line. And that is good to know, because if we've made a mistake on any of these, when we draw it, if it doesn't come out as a straight line, we know we've made a mistake. It says on the grid below, draw the graph, the same graph we just did, or we calculated the values for, between x equals 0 and 5. So we need to make sure that when we do it, we do not go into this bit over here, and we do not go over that side. Okay, so let's see. When x is 0, y is 8. So when x is 0, sorry, get it. When x is, let me just make sure it does. When x is 0, y is 8. When x is 1, y is 6. When x is 2, y is 4. When x is 3, y is 2. When x is 4, y is 0. And when x is 5 is 9. Now I didn't need to plot them all because it's a straight line, and as long as you were confident in your values, but there's no harm in plotting it all and then just drawing up to actually plot the line. Now remember, don't go more than 5 and then go more than 0. Don't go over here, don't go over there. Okay, nice, 3 marks, possibly for calculating that correctly and then for drawing it. Question 18. Oh, it's an angle one, so let's have a look. They tell us it's a trapezium, and yes, you can see that that's a trapezium. ABCE, ABCE, and it's made of a parallelogram, and here we have a parallelogram. And remember, parallelogram means that those will be parallel, and these will be parallel to each other. And an isosceles triangle, you can tell it's isosceles because we have those lines again, so those two sides are the same length, and they tell us AE equals DE, A to E equals D to E. Okay. Work out the size of the angle AED. So they're asking us to do angle AED, so this is the one here that we want, okay, all the way over there. Now the fact that these are parallel means that we can use our knowledge of parallel lines. Okay, so basically we have, that's a parallel line, and that's a parallel line, and we also have the other parallel lines. Yeah, so all those rules to do with parallel lines you will use. Now obviously they haven't drawn it very well, but they told us it's not drawn accurately. Okay, so if we do that, we will know that complementary angles, opposite angles are the same, and we'll also know that alternate angles, yeah, we can work that out. But from that we can see that basically that one there is 110, that one there is 110, so this one here is 110, and that one down there is also 110, but I'm just going to adjust, that's the one I need. Okay, and you might say, well, why do I need that? Because if I know that one, I can find this one, because that's a straight line, and if it's a straight line, 110 take away, 180 for a straight line, take away 110, leaves me with 70, so this side here is 70. How does it help? Well, if it's isosceles, that side and that angle and that angle will be the same, so they're both 70. So we know we have 70 and 70, so 70 plus 70 gives us 140, and we know that inside a triangle it all adds up to 180, so 180 take away the 140 from the other two angles leaves us with 40. So angle AED is 40 degrees. Okay. Now I've put the degree sign there, but I've now noticed they've actually put the word there, so I didn't need to do that. Question 19a and b are to do with sketching some graphs. This here is x cubed. Now if you know your graphs, you'll know the shape that should look like, but if you don't, just make a little table to give you some ideas. Okay, remember, linear graphs are straight lines, squares will have those U or upside down U shapes, so this one will be a different type of shape. And what I mean by that is just sketch, do a quick calculation of your x's and your y's. So for example, we could work out what it is when it's 0. When x is 0, 0 times 0 times 0 is going to be 0. So we know it's going to cross there. Okay, let's put x equals 1. If I put 1 in there, 1 times 1 times 1 is 1. So when x is 1, it's going to be 1, so it's going to be something like that. Okay, just made that up, you know. What I mean by that is I've just kind of approximated where 1 might be. If we put 2 in here, that means 2 times 2 times 2, which comes out to 8. So notice the next time we're on here, so we've gone 1, 2, it's actually shot up quite high, somewhere up there, yeah? So what we notice is it's shooting up. So let's see what happens in the other direction. So minus 1. Minus 1 times minus 1 times minus 1. So negative times negative times negative, negative times negative is positive, positive times negative is negative. We're going to come out to minus 1. So when x is minus 1, y comes out to minus 1. when it's minus 2 or negative 2, we're going to have negative 2. 2 times 2 times 2 is 8. Negative times negative is positive, times negative is negative. So it's going to make, and once again, when we're at 2, it's shot down somewhere there. So when we're sketching this, it's actually going to start from way down here, coming up, go through 0, and then shoots up. Now, obviously tried to make it smooth. It didn't go very smooth there, but you get the picture. Okay. Let's do the next one that they want us to sketch. And here we have a squared. Now we know that square shapes will be that way if it's a positive one, or that way if it's a negative one, so that's what we're looking for. But like before, you could always do a little table to help you approximately get an idea of where you're going to plot it. So let's put an X and a Y. So let's put an 0. So 0 times 0 is 0, plus 3, we're going to get 3. Let's try something like 1. 1 times 1 is 1, 1 plus 3 is 4. Let's put something like a 2 in there. 2 times 2 is 4, 4 plus 3 is 7. Let's go for negative 1, negative 1. Negative times negative is positive, 1 times 1 is 1, so 1 plus 3 is going to give me a 4. Oh look, it's symmetric. So let's just test if it works on the other side, so minus 2. So minus 2 times minus 2 is negative times negative positive, 2 times 2 is 4, so 4 plus 3, 7. So indeed it's symmetrical about this point. So when x is 0, it will cross at 3. And remember, it's a U shape. See, it's getting higher. So when it's 1, it goes up, and then it goes up to 7, and again on this side. So we want to draw a U shape if you can, trying to get a U shape going. Okay, now that's not very good because I really need the bottom bit to be about there, but since it says a sketch, I think I can get away with it. Let's have a look at question 20. And question 20 is quite a long one, a lot of words anyway, so we'll see. And it tells us we have a Venn diagram. And in the Venn diagram, it shows the information about the number of students who have a bike or skateboard. B is a bike, S is for skateboard. So inside the circle are people who have bicycles, and inside the circle are people who have skateboards. In other words, these only have a bike, these have a bike and a skateboard, these have only a skateboard, and anybody outside doesn't have a skateboard or a bike. There are 50 students altogether. So if we add everything together, it should come out to 50. So 10 plus 11 is 21, plus 23 is going to be 44, and 6 is 50. Yes, so it's correct. They tell us that a student is chosen at random. Work out the probability that a student has a bike. Now, probability is just writing a fraction. So we need to know that if you choose a student at random, it's out of 50 students. And we're looking for the ones who have a bike. And the ones who have a bike are 6 and 23. So 6 plus 23. 3 plus 6 is 9, so 29. So the answer is 29 out of 50. Okay, it's all the people who have a bicycle. Work out the probability that the student has a bike and a skateboard. So in this case, we only want the ones who have bicycle and skateboard, and that's going to be at 23 there. So we can write it down to 23 out of 50. Okay, and the last one is complete the sentence to make it true. The probability that the student something is 11 out of 50. So we look here and you see the 11 there, and that's the ones who have a skateboard but do not have a bike. So we need to do a question that shows that it's only people that have skateboards but do not have a bike, nothing else. So probability that the student only has a skateboard is 11 out of 50. In other words, make sure you don't have anybody with a bike. Excellent. We're getting through these quite nicely. Where are we? Question 21. Question 21 is a full page question, 4 marks. We have some working out space. We have here something that looks like it's for some coordinates. We have a graph, and it tells us here that a line passes through the points. So we're going to have to work through this and see what happens. A straight line passes through points -1, 2. So -1 here and 2, so for that point there, and 1 and 6. So it's 1 and 6. Let's just check. 1 and 6, -1, 2. Okay, and they tell us a straight line passes through those points. So let me draw my straight line. I'm trying to be as accurate in my drawing as possible. make sure I go through both of those points as well as I can. Okay, so here we have that line. Okay, they tell us another straight line has this equation x equals y. Now if you recognize x equals y, you'll know that x and y are equal. It means they have the same value, so whatever x you put, y is going to be the same. So for example, if you did a table and you had your x and your y, if x is 1, y is 1. If x is 2, y is 2, because they tell us they're the same. And because it's a straight line, we only need a few of these values. We don't need to have many points. So in other words, when x is 1, y is 1. When x is 2, y is 2. Or when x is 0, y is 0. So we're going to have another line that is passing through those points. So I'm just going to draw it, trying to get it as much as I can through all those points. Okay. And then it says, work out the coordinates. That makes sense because they give us space for coordinates of the point of intersection. And intersection is where they cross of these two lines. So we want to find out where they cross. And if you come down here, you will see that they cross there. Yeah, let's make it a little bit more clear. So it crosses at minus or negative 4. And it crosses at negative 4. So that's our answer. Full page, 4 marks, not bad. Question 22. Question 22 tells us in a month the number of hours of exercise taken by 10 people. So these are the hours taken by 10 people to do exercise. Which is the appropriate average? Oh, so we're talking about averages. You can see mean, median, most. So there's 3 options. Is appropriate. Tick a box. Give one reason for each of the other 2 averages as to why they are not appropriate. So if you remember, mode is the one that has the most, and that means the ones that are repeated the most. And if you look at that, we don't really have any repetition. So the mode's not going to be very good. If you look at the numbers, 4, 7, 2, 8, 5, they're all 1-digit numbers, in other words less than 10. Except for this one here, which is 82, which is huge in comparison. So if I go working out the mean, and the mean is adding them all together and then dividing by how many we have, that value is going to make it look like all these other people do far more exercise than they really do, because it's a huge number. So when you add them, it's going to make it a big number, and then you divide it, it's going to end up making it look like all these people are doing more exercise. So the best one to use in this case is a median. And the reasons are, I should write it as a sentence, should I? So we should start with a capital. There is no mode, and because there's no mode, it makes sense to not use it. And the other one is the very large value. I'm going to tell them I know which one it is. 82 would have a very big influence, or it would affect it, okay, on the mean, okay? Or you could tell them it would make it look like the other people exercised for longer, which is wrong. Okay, so we basically explaining that one big value there would make it look like everybody else is doing lots of exercise, and it's not really true, is it? Good. Okay, question 23. Question 23, part A, part B. Cards in a pack of red cards in a pack are red or blue in this ratio. So how many reds, how many blue? So this one here is your red, and this one here is your blue. What fraction of cards are red? So remember, fractions out of the total. So here we'd have a total of 5 things. So we want the denominator to be 5. So those are no good because those don't have denominator on the 5. So these are options. And we want the one with red, and red is 2. So that's the one we want. That would be the one for blue. We want the one for red. That's nice and quick. Let's have a look at part B. It says a different pack of cards has 72 cards in it. 5/9 are yellow. Work out the number of yellow cards. So it's basically 5/9 of 72. So when you do this one, you can either do your multiplication first and then divide by 9, or you could do your divide by 9 first and then times by 5. If you know your times tables, you will know that there are 8 9s, because 8 times 9 is 72. There are 8 9s in 72, and 5 times 8 is 40. So the answer is 40. Okay. You could have done 5 lots of 72 and then divide by 9 if you wanted to. You get the same answer. But in this case, it's really good if you can spot that how many 9s in 72. Do some cancelling and it saves you some time. Let's have a look at 24. Oh, more fractions. And here it's not very clear, but that is actually a division sign. Okay, so I'm just going to put that there so you can see it's meant to be a division sign. And it says give your answer as a mixed number. So we have mixed fractions, and we want to do our division, and then we want to return to mixed numbers. So we're going to change that into a top-heavy fraction. To do that, I do 2 times 8. I'm going to multiply those together and then add the top one. So 2 times 8 is 16, plus 1 is 17. So I have 17 on top and 2 on the bottom. And then we're going to divide it by the next one. Again, I multiply those together. 2 lots of 3 is 6, plus 2, so 6, 7, 8 out of 3. Okay. Apologies, it's not very clear, so I'll just rub that out there so that we can see what we're talking about. Okay. So we had 2 lots of 3 is 6, plus 2 is 8. Now when you do your division, you basically can keep the first one, change it to multiplication, and flip the second one. And then it's a case of multiplying the tops and multiplying the bottoms. So 3 times 7 is 21, carry 2. 3 times 1 is 3, plus 2, 3, 4, 5. So that's 51. 2 lots of 8 is 16. So we have our answer as 51 out of 16, but they want it as a mixed number, so we're going to have to find out how many 16s fit into 51. So you could just keep doing addition until you get there. So 16 plus 16 is going to be 12, 32. Add another 16 to it, so 6 plus 2 is 8, 48. You could add another 16 to it, and 6 plus 8 is going to be 14. 4, 5, 64, so that's going to be too much, isn't it? So that's going to be 58, 59, 60, 64, yeah, and that's not, we only had 51. So in that case we have 1, 2, 3 16s. 3 16s is 48, but we had 51 things, so what's left over, what's the remainder? 48, 49, 50, 51, 3 out of 16. So the answer for that one is going to be 3 and 3/16. Okay, don't like the way that's not so clear, so I'm just going to write it again. 3 and 3/16. There we are. Otherwise, you know, they might think that makes it a bit more clear. Ooh, we're on to solving. Some algebra and solving. So let's have a look. So here they say solve. Now remember last time when we solved, we wanted to get x on its own, and that's what they're wanting us to do here, to find out what the value of x is. But to do that, we're going to have to do a little bit of work, because we have the left hand side, but on the right hand side we have a bracket. So I'm going to expand the bracket, then I'm going to collect the x's together and the values and the numbers on together. So let's do that. So on this side we have 5x plus 3 equals, and if I expand this, I have 3 lots of x, 3x, plus 3 lots of 2, 6. To collect all my x's on one side, I'm going to take away this take away this 3x from this side. To do that, so I'm going to take 3x from this side, I'm going to take 3x from that side. If I do that, on this side will disappear, and I'm going to be left with just a 6. And on this side, I'm going to get 5x, take away 3x will give me 2x, plus 3. Now we continue doing that until I get my x on its own. In this case, I don't want that 3 there, so I'm going to take a 3 away from that side, take a 3 away from that side. So that means that that disappears. I'm going to be left here with a 2x. 6 take away 3 is going to leave me with a 3. Here we have 2 lots of x equals 3, so we'll divide that side by 2 and divide that side by 2. When we do that, I'm going to be left with the x, and in this case I'm going to be left with 3 over 2. You can leave it as a fraction, or if you don't want to leave it as a fraction, you could do a decimal. Half of 3 is 1.5. It's up to you. Okay, but that's the answer. You could always substitute it back in there to see if it worked, but I'm not going to bother right now. Let's have a look at part B. And part B, we have a long expression with some brackets and so we could probably look at expanding that. They tell us it simplifies to this. Find the values of a and b. Okay, so I'm going to have to expand and simplify. So I expand the first bit. If I focus on that bit there, I have 2 lots of x, 2x, plus 2 lots of 16. So if I double 16, double 6 is 12, carry 1, and double 1 is 2, plus 1 I carried is 32. So that has become this. Okay. Now it says plus, so plus, and now I'm going to work out that side there. Okay. 4 times x is 4x, and 4 times a negative 5 will give me a negative 20. Okay, so now we'll collect similar terms. Here we have a 2x and here we have a 4x. So if I collect them together, I'm going to end up with a 6x. And here I have a plus 32 and here I have a minus 20, and if I collect those together, I have 32 take away 20, which will give me 12. 32 take away 20 is 12. Or we can say 20 plus 12 is 32. Now remember, this is meant to look like that, but notice we don't have a bracket. Yeah, there's no bracket there, so I'm going to have to factorize it now. So let's factorize it. And when you factorize, you're looking for a common factor that fits into 6 and 12. And you notice that 6 fits in there and 6 fits in there. So I'm going to take the 6 out, which means I'm left with an x. 6 times x is 6s. If I divide that by 6, I'm left with a 2. Okay, so 6x, 6 times 2, 12. Now I can compare. They tell me this is going to look like this. It's going to look like an a bracket x plus b, and they want to tell me what it is. So you look at that, you can now see that the a is worth 6, and if I look at this here, the b is worth 2. That's actually quite nice once you've had a go at it. Okay, how are we doing? We're on question 25, and we're nearly there. There's 28 questions, so we have 3 more to go. Good stuff. Bit more algebra. This is using powers and the rules with powers. Now you can do it the long way, but in this case I would just recommend doing the power rules, which means that a, if you have the same base and you multiply them together, you add the powers. In this case 20 plus 5. So the answer here would be a. 20 plus 5 would be 25. Again, if you divide and you have the same base, you subtract the powers. So when I do that one, I'm going to get a 20 take away 5, and so the answer for that will be a. 20 take away 5 is 15. And when we have a power to a power, we multiply. So when we do that one, we end up with a 20 times 5. So the answer is going to be a. 5 times nothing is nothing. 5 times 2 is 10. That ends up being 100. 5 lots of 20 is 100. Nice 3 marks. It's very worthwhile knowing your power rules. Then we come down to question 27. Now question 27, this year you will have on your formula sheet the formula for a circle, both for working out the area and the circumference. So it's worthwhile knowing and understanding your formula sheet. Okay, so tell us this diagram shows a semicircle. Semicircle is half of a circle. They tell us the radius is 8. From there to there is 8. Work out the area of the semicircle. Give your answer in terms of pi. Now that's because we don't have a calculator. They normally will ask it in terms of pi. Sometimes they don't and you have to work it out, but today it's leave it in terms of pi. So the formula for an area of a circle on your formula sheet is going to look a bit like this, which basically means pi times your radius squared. And that's how you work out. But notice that would be for a full circle, and in this case we want half a circle, so at the end you're going to have to divide by 2 to get the area of a semicircle. So let's work it out. We have 8, so the area of the semicircle is going to be pi times the radius squared, and at the very end we'll divide by 2. So let's work it out. 8 times 8 is 64, so we're going to have pi times 64 divided by 2. Half of 64 is 32, so our final answer is going to be pi times 32, or 32 pi, and that's going to be the area of our semicircle. It's really worthwhile knowing your formulas on the formula sheet. Recognize where they are and which is which. Excellent. Last one. And the last one is to do with standard form. How do I know? I can see it there. Standard form, ordinary form, etc. It says a human cell has a nucleus and a diameter is so many meters. Write it in standard form. Then they tell us one that's in standard form, and they ask us to write it in ordinary form, and then there's a calculation down here, so we'll have a go at that. Okay. Now when you do standard form, remember that you're always going to have something like times 10, and the power is positive if the number is bigger than 1, and negative if it's less. Now notice this here is less than 1, it's a decimal, so it's going to be a negative power. Now you're only allowed to have one digit in front of the dot. You can have many afterwards, many decimal places, but only one digit, and here our first digit, zeros don't count, is 1, so 1. Okay, you can have zeros after it if you want, doesn't matter, or you don't have to. You could just, if you prefer, since we don't have other numbers to worry about, you could just write it as 1. Okay, so now we're going to see how many, the dot, notice the dot is at the end, so it's going to be there. How many spaces it moves? It's moved 1 space, 2, 3, 4, 5, 6 spaces to get there, so that's how many. And so your answer is going to be 1 times 10 to the negative 6. When we do this one, it says you're going to write that as an ordinary number. Now notice that's positive, so that means it's going to be a big number, bigger than 1. Okay, so when you do that, we're going to say 5. So that means the dot's at the end, and it's going to move 13 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and each of those is going to have a 0 corresponding each of those gaps. Okay, so in this case we're going to end up with a 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now you normally can't do that, because if the number were something like 5.3, you can't just add the zeros onto it. You actually have to move the decimal place to find out how many spaces there are to be filled in with zeros. In this case you can do it. Okay, then the last question tells us a patient has a disease. She has 4 to the power 3 body cells affected in day 1. The number affected cells doubles every day. On which day does the patient have 2 to the 10 affected cells? So notice this is 2 and that's 4, so what we're going to do is we're going to change that into the base 2. So if I do that, I'm going to end up with 4 to the power 3 is the same as 2 times 2 to the power 3, which is going to be the same as 2 squared all to the power 3, and if you know your power rules, you know that's going to be 2 to the 6. Yeah. Now they tell us that each day it doubles. So on day 1, so if this is day 1, she'll have 2 to the 6. On day 2 it doubles, so it's going to be that times 2. So if it's times 2, it's going to be another 2 in there, to the 7. And then on day 3 it'd be another times 2, so there's another 2 there, that's times 8. So day 4 we'll have 2, 8 plus 1 is going to be 9, and so on day 5 she will have, oops, made a mistake, I was thinking of that 9 plus 1 is 10, so we should have here 10 to the 10, which is what they told us we were looking for. That is on day 5, so on day 5. Well done, I think we've finished. Let's just check. That's question 28. Very well done. Hope you enjoyed that and hope it makes some sense. Bye.